While the bridge joints are cooling, let's start working on some of our braze-ons. Here we have a double stop that we're putting on for cable brake cable routing. Easy to hold this in place, just a modified C-clamp holds it in place, and we're going to silver braze it on. Cleanup on these two bridges will be by hand. There won't be any dynaphile work done here. We're just in too tight a quarters down there to risk bringing the head of that dynaphile in contact with other parts of the frame. So this will be all done by hand filing, and the final sanding as well will be done by hand, by sanding underneath my thumb with the emery cloth strips. Was done earlier, the object here is to remove all the high spots, any bumps or whatever that are in the fillets that we brazed on here. And also we want to make sure that we're removing little or no steel while we're doing this cleanup. Said earlier, no dynaphiling here. This is all going to be sanded by hand. This bike is going to be outfitted with cantilever brakes, so we're going to choose a cantilever brake cable hanger. There are quite a few to choose from, different styles. These days, a lot of people are using V-brakes, so if you're using V-brakes, you do not need to have one of these cable hangers. You can just skip this step. Here we're flexing up the area for the brake cable hanger that we've chosen. We're using a kind of a smallish one. And it's really easy at this point to also braze on your spools for a rear rack. And I always use a piece of just some welding rod large enough to go through the insides of the spools, and just drop them in place just like that. And that rod holds them in place quite nicely. After you get done brazing, just slide that rod right out. Holds them in line with each other quite nicely. And brazing on these goes pretty fast. Since the spools are kind of thick, you don't have too much trouble with them overheating. And also that brake hanger is fairly thick, so you don't have trouble with that overheating. Make sure to float enough silver underneath those so that you have a nice little fillet all the way around underneath the spool. Any break in the fillet could be a place where you're lacking strength, where that spool could break off. Again, we're using an 035 tip here, a long, quiet carburizing flame, and 16th inch 56% cad-free silver. We're putting in those two little water bottle fittings into the two bridges for fender mounts, and these will braze up quite quickly. One in the seat stay bridge, and we've got another one down here in the chainstay bridge. Doesn't take much to hold one of these in place. Just a drop will hold that water bottle fitting in place on the bridge. Try not to get your silver into the threads in there. You'll have to run a tap through it later, and it's kind of difficult to twist a tap down in close quarters like this. Perhaps the best surefire way to locate either a cantilever brake unit or a V-brake unit is to put the braze-on stud into the caliper unit and then mark with the needle file a little scratch mark that shows the center of the braze-on piece. This will pretty well determine exactly where that brake unit needs to be, and disregard the fact whether you've got a wide rear end or a narrow rear end or whatever. On the front, we're going to do the same thing. We're mounting cantilevers on this bike. U-brakes should be able to drop right onto the same studs, so whether you fit this with cantilevers or U-brakes, it shouldn't really matter. Henry James also makes an excellent fitting that will locate the cantilever studs or U-brake studs and then hold them for brazing. Here I'm using a cantilever brazing jig of my own design, and it handles a variety of widths and wheel diameters and so forth. Again, the Henry James jig is available to anyone who wants to purchase one. You don't have to reinvent the wheel. Just purchase his, go to his website and purchase his. When you're brazing cantilever studs on, it's a pretty easy process to do. The cantilever studs are fairly thick. The fork blades are fairly large in diameter and relatively thick, so you can work without too much worry of overheating. However, I would definitely make sure to follow some of the practices mentioned earlier in the video, particularly pointing your flame away from any piece of tubing, letting your heat skim off into midair rather than pointing directly at a tube. This should take no more than 5 minutes to braze on a pair of these. Here we're setting up the rear studs. These are all silver brazed on. I always silver braze my cantilever or V-brake studs on. We're using a white water-soluble silver brazing flux here. This cantilever fixture is kind of complicated. It works very well, but it has a lot of pieces to it. In chapter 9 of my book on frame building, near the end of the chapter, brazing on cantilever studs is covered in pretty good detail, and also there's an alternate type of very simple fixture that can be made out of a piece of strap steel, and that little fixture is shown in pretty good detail at the end of chapter 9. Want to save some time while putting your braze-ons on? You can have your brake cable hanger and your rack braze-ons and your cantilever studs all lined up here and ready to go, and braze the whole bunch all at once. Here we have a chain hanger held in place with a modified C-clamp on the seat stay, and right now I'm brazing a what I call a diver's helmet cable stop on the underside of the chainstay. It's very easy to take cheap $3-4 C-clamps and modify the ends on them so that they'll hold various shaped objects. I have a whole drawer full of these modified C-clamps. Of course, it renders them useless for woodworking, but they make great clamps to hold things in place while brazing. Takes just a dab of silver, just a drop, to put these two items on. We're going to have to tap and face our bottom bracket one last time. Here I'm using a little tiny wire wheel mounted silver soldered into a 5/16 by 028 shaft to clean out all the grit from the Dynafile and the emery cloth strips. That grit can quickly dull your cutting tools. And of course, as we did the first two times we tapped and faced the bottom bracket, we used plenty of cutting oil. And I'm going to turn these taps just enough, maybe 3 or 4 turns, to anchor the first 3 or 4 threads in the bottom bracket shell. Then I will bury one side all the way to the end of the flute, adding cutting oil frequently as I do it. And then I'll back that side back out, not all the way. I'll keep it anchored last 3 or 4 threads, and then I'll go to the other side and bury the other side to the end of the flute. Of course, bottom bracket taps obviously are made to turn in either direction, unlike reaming and facing tools. And I back that first side out, and now I'm going to bury the second side. At this point, it's really easy to find exactly which side your left-hand thread is on, because the bike is completely assembled and there's a derailleur hanger on one side of the bike now. That derailleur hanger is on the same side of the bike as the left-hand thread. So just make sure that you're putting the left-hand tap, the one marked LH, into the same side of the bike that the derailleur hanger is in. Here we're putting in the bottom bracket sleeves provided by Campagnolo and Cobra. These bottom bracket sleeves, as I mentioned earlier, provide a precision bore for the bottom bracket facer to locate on. Also, we'll leave these sleeves in to do our alignment on the alignment table. Just push, screw them until they bottom out against each other. Again, make sure to apply grease to the shaft. This grease will use up some of the clearance between the shaft and the sleeves and cut down somewhat on your chatter. Don't forget, reamers and facers are never turned backwards, so don't turn your bottom bracket facer backwards. It will dull it fairly quickly if you do. We're going to be taking kind of a light cut here. Earlier, it was acceptable to face so you had it clean 3/4 of the way around the bottom bracket shell, but this time we're going to face until we have it clean all the way around. And we're also going to be taking a fairly light cut. We don't want to overdo it here. Remember, we started with about a 69 millimeter bottom bracket shell, and we're shooting for 68. If you go a little bit undersized, it doesn't really hurt things too badly. You don't want to go a lot undersized, but to go maybe a 1/2 millimeter undersized is not really going to harm things. I have seen some bikes in the past that were actually 2 millimeters undersized for bottom bracket width. That's getting to be a bit much. Now just check your bottom bracket faces with a vernier caliper or a digital caliper. Hopefully you're right on at 68 millimeters. Clean away a few of the chips before we put this on the alignment table. Resting on a chip could throw off your readings. And then we'll take the frame and we'll put it on the alignment table. Don't forget, our bottom bracket sleeves are still in place and they locate on the shaft of the alignment table. And we'll put the large brass nut on here. Incidentally, there is a set of plans for an alignment table just like this one in the back of my book in Appendix D. Tells you everything you need to make and everything you need to do to those pieces to come up with a whole complete alignment table. Also included after the tail end of this video is my frame alignment video. It's a 30-minute video, and it shows how to use one of my alignment tables that you build from the plans for fixtures. So after this video is over, stay tuned because that'll be coming up next. Here we're finding the center line of the seat tube, basically the imaginary central plane of the frame. So we're measuring to the top of the seat tube, and then we're going to subtract the radius of the seat tube, which would be 14.7 millimeters for an 1.125" tube. And I'm just going to jot it on the frame so I remember it. That's my imaginary central plane of the frame. Then this is going to be a 135 millimeter rear end, and so I'm subtracting 67.5 millimeters from that imaginary central plane, and I just wrote it on the inside face of the lower dropout. Now you can add 67.5 to that central plane, and then I also add an additional 7 millimeters for the thickness of the dropout, and I just wrote that on the upper face of the top dropout. And then I'm going to cold set this frame so that those two faces come out right at those two levels. And theoretically, if you cold set it to that point, everything will be in the same central plane and it will have the right bottom bracket spacing. excuse me, not bottom bracket spacing, rear triangle spacing. And here we go. We're taking a Park wheelbarrow handle. A lot of people call it the Park wheelbarrow handle, and actually you could do this with a wheelbarrow handle. Just go down to the hardware store and buy one. We're bracing against the seat tube close to the bottom bracket, and we're cold setting that left dropout downward. Sometimes it takes 2 or 3 tries. Sometimes you go past it and you have to bend upward a little bit. And now we're going to reset our vernier height gauge. You can use a vernier or a digital height gauge. Either way is fine. This particular height gauge is made by Mito Toyo, and it has both metric and English increments on it. Now we're going to insert this cheater bar the other way, and we're going to bend down a little bit. Get those 2 readings just right, and that rear end should be set just right for us. And don't forget to watch that frame alignment video at the tail end of this video. I like to stamp the serial number while the frame is still held in the frame alignment table. It's nice and rigid, it won't move around on you, and there's less chance of getting a double strike on any of the numbers. Some frame builders have a very detailed serial number system that tells them lots of information about the frames that they build. The serial number system you use is up to you. You can just do something simple, 001, 002, 003, and on up for each frame you build, or you can include numbers that describe the tubing used, or whether it was a road bike or an off-road bike, or what type of lugs were used, or if what type of dropouts were used, whatever, or warranty information, whatever you like. Here I like to put a duplicate serial number in the steering column right above the Crown Race press fit area. And don't put it in the Crown Race press fit area, put it slightly above. This is a nice place to put a serial number because if the bike is stolen, the thief is not expecting a duplicate serial number on the steering column. Plus, it's hidden from view. And, this may be just the thing that helps you retrieve your bike. One of the very last things I do on my frames is clean up the tabs on the dropouts. I clean them up so that the dropout tab flows nicely into the seat stays and into the chain stays. If this hasn't been done to the forks, you could do it to the forks at this time too. Just clamp tightly in the vise and just clean that up a little bit. You can do a final sanding either with emery cloth strips or with a Dynafile. And of course, to get all the different angles on here, you'll probably have to flip this frame 2 or 3 times, maybe 4 or 5 times to get all the different angles. They're difficult to get all clamped at one location, but if you flip the frame like we've done here, you can hit a different area. And here we have some quick cleanup with a Dynafile. Very light touch. Don't remove too much metal. Makes quick work of it. And as I've done everywhere else that I use the Dynafile, I do finish off with some emery cloth strips. Just kind of ties that joint together and makes it look a lot smoother. Chadwick reamer, Chadwick number 28 adjustable reamer, and we can adjust the size of it by screwing the rings down toward the end of the reamer to make it smaller, or screwing them back up toward the handle to make it bigger. This is a number 28, and this is a size that I use always for 1 1/8" seat tube. The last steps we're going to do here is we're going to ream the seat tube. We're going to slot the binder slot, and then we're going to hone the seat tube. I always save this to the very end because of the distortion that could occur while I'm cold setting the rear triangle. I'd rather save this last business for the very end of the frame. One thing that people make a mistake on is they think that the reamer can be used to increase the intended inside diameter of the tube. That is improper. You want to run this through the joint area, which has possibly become a little bit egg-shaped. Even though the heat sink plug was in there during brazing, it still has a tendency to go a little tiny bit egg-shaped. And we're taking that little egg shape out of there. And all we want to do is we want to remove enough material so that the inside diameter going through the joint will match the inside diameter below the joint. We do not want to go bigger than the inside diameter that is below the joint. That would be an incorrect procedure. Again, a reamer always goes clockwise. You never turn a reamer backwards, even an adjustable reamer. Turning it backwards will dull it. On your final pass, now that slid through pretty fast after it went through the joint area. On your final pass, you'll want it to have just the tiniest amount of resistance after it passes through the joint area. I like to clean the chips off every 2 or 3 passes with this tool. I like to clean the chips off, and we're adjusting it just a little bit bigger. Each time I make a pass, I adjust the rings about 1.5 turns. No more than that, maybe even just 1 turn. If you go more than that, you'll be taking too big of a cut. Here we go. This is probably the final pass. You don't know until you get through the joint, because it's going to give you some resistance through the joint, noticeable resistance through the joint. And then as it goes past the joint, you should feel just a tiny, tiny bit of resistance. Maybe another pass. Notice I'm continuing to turn it forward even when I'm removing the tool. You do not turn it backward even when you remove the tool. Using my abrasive cutoff wheel with the die grinder, the electric die grinder, to cut my binder slot. And this particular cutting wheel is a 1/16 of an inch wide. It cuts just about the right width on that binder slot. I have an 1/8 inch round carbide burr mounted in the die grinder, and I'm shaping a little stress relief area, a little rounded stress relief area at the bottom of the binder slot. The final step is to hone the inside of the tube to break off any little chips or anything that might be in there that might scratch your seat post. I just used a brake cylinder hone here. Does a nice clean job, and there we can check with the seat post. Nice fit. I like to keep the 3 main tubes of the frame clear until the very end. That way I can clamp with the park stand wherever I want to without damaging anything. So I'm going to put my water bottles in, and I'm going to put my top tube guides on right now. Basically here I'm just splitting the difference in the middle for the center guide, and I'm measuring in about 6 or 7 centimeters for each of the end guides. And I'm putting a little file mark there, just a tiny file mark with a jeweler's file to tell where those guides are going to go. One way to locate water bottles is to just use an old water bottle cage. Actually, these are new water bottle cages, but use a water bottle cage to locate where the bottle should be, and then with a Sharpie marker, just mark where the actual hole is going to go. Water bottles can go in lots of different locations. Standard locations are usually one on the down tube and one on the seat tube. I'm mounting this one a little bit low, so I did measure to see where my derailleur strap is going to be around the seat tube, and this water bottle is actually going to straddle that derailleur strap. Of course, you'll have to punch with a center punch to locate that hole, or your drill bit will wander while you're trying to drill that water bottle hole. Don't overdo it with this center punch. You could put a really bad dimple in the tube. I like to use a right angle drill because it allows me to get in close with these smaller frames. And try not to hit the opposite side of the tube while you're drilling. The first hole I drilled was a 3/16. It was basically a pilot hole, and now I'm opening this up to a 1/4 inch hole, which is standard for all water bottle fittings. Water bottle fittings are definitely the easiest braze-on to put in. They require a very small amount of heat because they are small and they're on a thinner part of the tube, so make sure and point your flame tangentially to the tube. Don't point directly at the tube. This is a thin area and you could burn a hole through there very easily. Just a couple little drops of silver are all that are required for water bottle fittings. Keep that flame kind of flat. Don't point into the tube. Here's a neat place to put a pump peg, right on the underside of the left seat stay. Keeps that pump located in an in an area that it won't get knocked off or bumped against. Without a pump underneath the top tube, you can more easily sling the bike over your shoulder and carry it during an event. I just put a drop on, drop of silver on, and then I hold the pump peg with an old pair of beat up needle nose pliers and reheat that area and keep the pump peg close, and they come up all to the same temperature at the same time, and it drops into place. Hold it for a second and it's there forever. Here's a neat way to hold your top tube guides in place, kind of like the man at the circus on the high wire. You take a piece of rod and give it a little bit of a bend and just lay it right across the top of that top tube guide, and it'll kind of balance itself while you're adding your silver. This little piece, of course, can get quite hot, and another hassle is you could silver braze that rod to your braze on. Again, you're in a very thin part of the tube, so be very careful here so that you don't overheat. And here we are putting the final touches on the third top tube guide. Okay, here's our final frame. It's all done, just about ready to go to the painter. About all that has to be done now is a final cleanup. You can remove a lot of these black splotches that we have around our braze-ons with some snow bowl and a toothbrush and some hot water. I would also recommend, as a last preparation before going to the painter, to go down and buy yourself some DuPont 5717S, which is DuPont Metal Prep. Its active ingredient is phosphoric acid, and run that about 50% water, 50% metal prep, and also work in a ventilated area, and get some rubber gloves, and get one of those greenie pads down at the kitchen section at your local grocery store, you know, those Scotch Brite green scrubby pads, and go over the whole frame with that solution of water and 5717S and completely clean it up. After you get it all cleaned up, you'll want to dry it off thoroughly. I'd use compressed air. I'd also flush inside the tubes with that same solution. And when you get done, clean it up thoroughly and dry it off with a terry cloth towel and compressed air. Blow inside your air expansion holes here. Try to blow all the fluid out that you possibly can. And after you get done doing that, you're ready for your paint job. And good luck on doing your first frame. Hello, I'm Tim Paterek for United Bicycle Tool Supply, and if you're watching this video, you have probably recently purchased a frame alignment table for bicycle frame alignment from United. And let's unpack the table first, so let's go on over here. All right, you'll take a drill or something, a drill or screwdriver, and unscrew all the screws on this box to get this thing open. All right, inside here we've got some packing material, and you're going to find some things that you're going to have to unpack, so be careful. These are precision ground items and you don't want to be dropping those. So pull everything out of here and set it on a table. Then you're going to have to take out this shelving right here, 2 screws. Take the shelving out and take the supports out on the inside. All right, this alignment table is pretty heavy, so make sure and have a friend help you pull this thing up out of here. Let's take a look down inside here and see what we can grab onto safely as we lift it out of here. You can either grab onto the handle right here or like this, or you can reach down and grab this 1.1/8" bar close to the clamping assembly. Don't grab it way out at the end. Grab it in close to the clamping assembly. And a friend can grab onto the threaded shaft up at the other end and just lift this thing straight out and onto the table. When you got your table legs have been put in here upside down. So you're going to have to unscrew the large nut and washer underneath this end and lift this out like so and invert that leg. Remember, this is heavy, so you may want to have a friend to help you. And then take your bottom bracket post and screw it onto the top side like so. And when that snugs up, take a large wrench, make sure and use something really big like an 18-inch wrench, put it underneath there and torque that thing down really tight. Give it all you got. Get that thing super tight. Then we'll go down to the other end, right down here, and we'll invert these 2 legs, have them sticking out through the bottom, and we'll torque them tight, and so that the legs are flush on top. And then this is an extra. The nut and washer, the large nut and washer at the bottom bracket post end can be tossed away. You can do whatever you want with them, spare parts, whatever. Okay, the table is all unpacked and we've got the legs inverted, and now we need to choose a bench to mount this to. Make sure that you choose a very heavy-duty, rugged bench. Do not use any kind of particle board, because when you start reefing on a frame and torquing some heavy-duty frame that's really badly bent, you could go right through the top of a composite or fiberboard type bench. Make sure that the bench has a minimum thickness of a 1.5-inch top. The thicker, the better. And again, do not use any type of composite wood. Use regular lumber. Let's take a look over here and see how we're going to mark these holes. I'm just going to take my Sharpie marker and draw a circle around all 3 holes. One there, one here. You'll also notice that I've taken the washers and 1 nut off the bottoms of these legs. Get those out of the way and we'll put them back on later. And we'll mark the 3 holes like that and we'll drill them. All right, we're going to drill these holes with a 1-inch drill bit, and probably just one of these spade drills would be the best, as you can see. They'll go through a variety of different types of wood, and just center that little point there, and let's go on down through. And go ahead and drill all 3 holes. Now we're going to level the table, so if we just pick up on a corner here and run that bolt down, you can just level it by eye. It's not really necessary to have your table perfectly level to function, just be appealing to the eye to look nice and level. Now we put the large nut and washer underneath the bench on the bottoms of the legs, and now we can just tighten it down from the top and tighten this down nice and tight. We want to make sure this is really secure so that when we start bending on these frames, they won't throw things off. We're going to have to prep our bicycle frame to get it ready to align on our table. What we need to do is we need to tap and face the bottom bracket so that the bottom bracket faces here are parallel with each other. And first step in doing that is to tap out the threads. We need to use a set of line taps. These are line taps because they fit together like that, and they tap on that line so that they're in line with each other. You need to use a set of either Campagnolo or Cobra. These are Cobra taps right here, or Bicycle Research, VAR, Park, GPM, or Silva. Those are all really good quality bottom bracket line taps. Don't use the type of taps that only go in one at a time and use a wrench to turn. It's not going to do a sufficient job. We're going to make sure and put the left-hand tap, this one's marked with an LH for a left-hand thread, we're going to put that in the left-hand side here. And if you run down, you can see that the derailleur hanger is on the same side of the bike as the left-hand thread. So make sure you don't get that turned around backwards or you'll ruin that bottom bracket. Okay, and we need to use cutting oil. Use cutting oil, not motor oil, because cutting oil has chlorine and sulfur added to it, which both improve the quality of the cut and keep the temperature cool as the cutting is going on. Cutting does generate friction, which also generates heat, and we want to keep these cutters cool. Run those cutters in right till you hit the end of the flute, and then back them back out, and we'll get ready to face after that. We're going to face the bottom bracket shell. The best tools you can use for facing a bottom bracket shell would be Cobra, Campagnolo, Silva, and GPM. And the reason I recommend those is because they all use the precision sleeves that go in the center of the frame. When these sleeves screw in, they will provide a precision bore for your facing tool shaft to go down. And with that precision bore, you'll get a much better quality cut. You'll get less chatter, and you'll get much more parallel faces. Your faces will be closer to being parallel if you use those. And here's our facing tool, and one thing I like to do with the facing tool is I like to put a little bit of grease on, put it on the shaft. That will cut down your chattering, and it's really kind of a neat product. It's a spray-on lithium grease made by Gunk. Terrific stuff. Go ahead and insert this through the bottom bracket sleeves, and then we'll put on our large washer, spring, small washer, and threaded nut. And this doesn't require a lot of pressure. You don't turn this tool backwards. You always go in one direction, always forward. And clean this up until this surface around here is clean and shiny about at least 3/4 of the way around. Then when you're done with that side, stick it in the other side, put the pieces back on, and we'll face the other side. Be careful that you don't do this with the tool too tightly, or it will take off too much material. When you finish up, back that nut off and take a finishing cut. And there we go. Our faces should now be parallel, and they should be clean and shiny, about at least 3/4 of the way around that surface. About 3/4 of this surface should be clean and shiny at this point. Let's take the tapered shaft out of our alignment table and set it aside because we won't be using this yet. Set that underneath, that'll be fine. It'll be in our way for this procedure. Then let's unscrew the large brass nut, large brass washer, and then there's a sleeve right here. This sleeve is in case you don't have the type of bottom bracket facing tool that uses the precision sleeves. Since we've got them here, we're going to leave them in there, and we're going to drop this frame over the shaft like so. if you don't have those precision sleeves, you can drop this onto the shaft and then drop the frame over that, and it'll keep it centered a little better. Put the brass nut back on. And we're going to set this up so that the down tube right here is over the surface of the table. I like to use the actual frame itself, like a wrench, just like that, nice and tight. All right, we'll take our universal surface gauge and we'll set it up so that it just ticks the top of the tube, just like that. You can probably hear it. And then we'll slide out here and we'll see if it ticks the tube there. It doesn't tick the tube there. That means the tube is going downhill. So we're going to take probably a 2x2, particularly one made of oak, would work just fine. Should be able to get that down at the lumber store. And just put it underneath there and bring this up like so. Be careful, don't overdo it. You can put a dimple in down here, down close to the brass nut if you overdo this. So just kind of test and check, test and check. Swing over here. We're not hitting yet, so we need to bring it up more. And we're going to keep torquing on that until we get it to hit. There we go. Okay, so we should be getting a noise there and a noise there. And that means that this tube is parallel to the table. All right, we can grab onto the frame, loosen the nut. If you need to, just use the cheater bar that you got with your table to loosen that nut. Now we're going to swing it so the seat tube, right here, the seat tube is now over the table. And again, you can use the frame to tighten it up. And we're going to take a reading with our universal surface gauge down at the bottom bracket shell. And we'll take another one up here. We got a little clearance there, so we need to take the cheater bar that came with your kit, with your table, and we're going to slide it in against the bottom bracket shell, and we're going to bend up. And we'll bend up and we'll check until we know that we've got the same sound, or the same kind of tick sound with our universal surface gauge at each end. And then we'll know that this tube is parallel with the table. All right, now we're going to check for head tube twist, and we're going to take our universal surface gauge and we're going to touch the inside of the bore, right inside there. There we go. We're getting a little scraping noise right at the very bottom, right at the very bottom of that bore. Get a little scraping noise there, and then we'll swing the frame, tighten it back up, and we'll turn this around, and we'll see if we get the same little scrape. See if we have any head tube twist in here. And I would say if you've got more than 0.5 millimeter difference between the two readings, it would be a really good idea to try to take out the head tube twist. Now here's how we're going to do that if you need to take out head tube twist. One thing you might want to invest in would be an indicator to put on your universal surface gauge. And this is what I like to use when I'm inspecting bicycle frames. Take it up here a little closer, you can see it. It just fastens right to the universal surface gauge, and you can get much more exact measurements on things like head tube twist. I know I just recently said to look for 0.5 millimeter of head tube twist. Actually, that's quite a bit of head tube twist, and if you were to use one of these, you could get your quantities down much lower, so that you could be looking for 0.1 millimeter of head tube twist, or maybe even less. Now we're going to line the seat cluster, the seat tube, up with our clamping assembly up here, and we're going to take our tapered shaft, which was in the clamp when you unpack the alignment table, and we're going to line that up right here like so. Slide your V-block in there, and we're going to clamp that down so that this is all anchored between these 2 points. Then we've got an outrigger underneath here. We're going to swing that outrigger out, and then there's a nut under here. You want to tighten that nut up and make sure your outrigger is stable and steady. And then we're going to take our head tube jack. We're going to put it right underneath the head tube, and we're going to jack up right there, right up underneath the head tube. There we go. We're supporting the head tube right there. And if we want to twist the head tube this way, torque down, twist the head tube that way. If we want to twist it the other way, we would move our jack out underneath the other end of the head tube, slide the bar in, and push down that way. Be careful, you can really torque with that much leverage, 3 feet of leverage, you can really torque. So be careful, take it easy, and bend and check and bend and check. Don't try to do it all at once. When you're done removing the head tube twist, you can put your jack away and swing your outrigger arm back underneath the table. Okay, here's our dropout centering gauge, and this is your what I call a dummy wheel. And on the end we have 2 cylinders, and the cylinders that came with your set right here are they're marked a 130. So if you put the pair of 130s on here, it'll be the same as a road rear end. And the other set will be a set of 135. So if you take those off and put them on here, it'll be the same as a mountain rear end dropout spacing. So right now I've got a set of 126s on here because I'm gonna cold set this. This is kind of a retro frame, and I'm going to cold set it for old style road. And if you want to order different sizes here, you can order 120s for really old road bikes, or 126s for vintage road bikes, or you could order 110s. Just order those from United Bicycle Tool Supply. They are $25 a set. And you can screw those right onto your dropout centering gauge. We're going to take this dropout centering gauge over to the seat tube, or the down tube, close to the bottom bracket shell. We're going to loosen up here, and we're going to drop that, and we're going to touch that V. Touch the V right against the down tube, close to the bottom bracket shell, and when we get it just right, that'll be just centered just right. Then we're going to swing this around, and we're going to see how we come between the dropouts. And it looks like we're going to have to torque those dropouts apart a little bit. So we're going to stick our cheater bar up in here like so, and we're going to bend down until the gauge passes between. Bend down again until the gauge passes between. This may take several tries to get the right distance in between there. The top, you may have to bend the top down a little bit to pass between there just right, or you may have to bend the top up. Notice I'm putting this close to the bottom bracket shell right down here, and bend up. Get it so that the dropout center gauge passes right between the dropouts just right, and those dropouts will be in the same center line as the tubes are up here. All right, you can also straighten bicycle forks with your alignment table, and we're going to do that right now. We're going to move up to the other end of the table where the clamping assembly is, and we're putting a fork inside here. You can see that the clamping assembly will easily grip a steering column of a fork, and it'll grip any size, inch, inch and an eighth, inch and a quarter steering columns. Now you can see that with the dropout centering gauge, I have removed my cylinders, and by removing the cylinders, that makes this a 100 millimeter width, which is standard width for a front wheel. And here I'm going to center my V on my alignment gauge on the steering column. Incidentally, if you're not at quite the right angle, this little wing bolt will modify, it'll adjust to whatever angle you want it at. And so we are now touching right in here, and that means that the 100 millimeters is centered on the steering column. And then we're going to slide, we're going to open this up, slide the steering column in, and I'm going to take a machinist square. You can also purchase a machinist square, 6-inch machinist square through United Bicycle Tool Supply. And we're going to take this machinist square and we're going to put it against the back side of the fork blades. And tighten. Don't over torque. You can actually distort your steering column by torquing too hard on that. It doesn't take much to hold that fork where it needs to be. Okay, so we can bump that square into the back of the fork, just below the crown, and we can bump it at the tips, and this looks perfect. But if we wanted to change it, we could take a Park FFS1 frame and fork straightening tool, which is also available from United Bicycle Tool Supply, and we can take that Park FFS1, put it against the fork crown, grip out here near the end of the fork blade, and we can torque this thing straight so that we get the same reading here and here on the tips as we get here and here up at the top. Then we take our dropout centering gauge and we slide it in here. Looks like this one has to go down, this one has to go, they both have to go down a little bit. If you want to, you can flip the fork and work from the other side, so you can be pulling up like so. But anyway, get it so that both of the fork ends go between the dropouts. And when you get the fork square at top and bottom, and the dropouts right even on the dropout centering gauge, your fork is nice and straight. Just a quick word about using alignment tables. There are a number of them on the market. Some of them are quite expensive, some of them are moderately priced. The one thing you'll find about alignment tables is if you take your bike and align it on one table and then go to another table and check that alignment, you will probably find some error. It's very difficult to get away from that error. Once you align it on one table, you should be happy with it. Don't move on to another table to find out if it checks with that table. In fact, don't even expect to get the same reading if you're using two tables of the same brand. You're going to get a little bit of error there as you move from one table to the other. After your bicycle frame has been aligned, stick with that alignment. You will get some error if you move to another table. You will also get error if you flip-flop the frame. If you align the frame to the left-hand side, with the left-hand side of the bike down, and then you flip that frame in the alignment table, you will also get some error readings. So when you do your alignment, try to do all of your alignment from one side of the frame always. Just keep that in mind, and you'll just cause bad feelings by going from one frame builder to another, checking out how the alignment is from one table to the next. It's not going to make you happy, and it's not going to make the frame builders happy. All right, here are a couple really big no-nos for your table. First of all, people like to have a can of pop, like to have a cold one, and where do they put it down? For some reason, they always find that table. That's probably one of the biggest no-nos you'll ever have in any machine shop or any shop that has precision ground surfaces. Do not put a cold drink on the surface of that table, whether it's a glass full of ice water or if it's a pop can, because that's going to leave a ring, a wet ring there. You're going to walk away, and a few hours later you're going to come back to a little rust ring there. And of course, if there's a cola product in that can, you may have some severe corrosion taking place in only a few hours. So no cold drinks on that table. Another thing to watch out for is swimming pool chemicals, hot tub chemicals, fertilizers. Keep all of those substances away from your table. Don't even store these substances in the same room as your table. These acids can mix with atmospheric air, and you can actually have rust forming on the surface of your table simply from the presence of the molecules of this stuff in the air that you're breathing. So hot tub chemicals, swimming pool chemicals, fertilizers, any kind of caustic or acidic chemical, keep them away from your table. Let's talk about care and feeding of your alignment table. And this also goes for just about any alignment table that's on the market. Some of these little hints I'm going to cover. Some of the things you'll need, you can get this honing oil. You can get that at just about any sportsman's shop. That's for putting on honing stones for sharpening knives, and we'll be using that to take care of our table. This is navel jelly. You can get navel jelly at just about any hardware store, and that's a rust inhibitor and a rust eliminator. WD-40, you can buy that just about anywhere, including grocery stores, so I have a can of that on hand. This is a stone, a sharpening stone, a honing stone. Average grit. I wouldn't go super fine like hard Arkansas or anything. I just go medium grit. And then you can get these just about anywhere. This is a greenie pad or a Scotch-Brite pad, and it's really good for removing rust. First off, if you do get some rust on your table, which could be expected, especially if you're working anywhere near the ocean, or if you're working near any corrosive chemicals or something, or if there's any moisture in your shop, you may be developing rust on your table. So just take your Scotch-Brite pad and find that area where the rust is and just work it out. Just buff it out. It should come out if it's a really mild case of rust. For any worst cases of rust, you can take some navel jelly, and this is kind of a hot pink in color. You'll know you have the right stuff if it's hot pink. And if the rust is a little bit deeper or a little bit harder to hit, you can put some of this right on the table. A little bit of water will make the navel jelly a little bit more active. It works better if it has a little bit of water with it. And just add that to the table. Your table will develop a slightly different hue in color after using the navel jelly. That's basically an iron phosphate on the surface of your steel table. This steel table, by the way, is not plated. It's not available in a plated model, so you need to watch this rust, and you need to keep up on it all the time. If you ever develop any rust, you can go over the whole table with the navel jelly if you like. Just completely wipe down and scrub the whole table with the navel jelly and a damp Scotch-Brite pad. When you get done, you can wipe all the excess navel jelly off, and then take a paper towel or something and completely wipe off that surface. Make sure it's completely dry. After you're all done with that, you can spray down the whole table with WD-40, a generous amount of WD-40. Make sure that whole area is completely covered with WD-40. It wouldn't be a bad idea. You can go ahead and take your dropout center gauge. The dropout center gauge is made of aluminum and stainless, but if you want, you can just shoot a little WD-40 on that. Doesn't hurt it. And your head tube jack, go ahead and shoot that with a little WD-40 if you like. I would not store these items on the table. I would store them somewhere else on another surface. Sometimes people drop something on their table. You may drop something and get a nasty ding in that table. If you do get a nasty ding, say we dropped a heavy wrench or something, or a heavy piece of metal right there and got a ding. You'd take your honing oil, drop some honing oil in that spot, and you take your honing stone, and with circular motions, you'd hone that area like that, circular motions, and eventually you should be able to flatten that little ding down flat again. Your table, eventually, after several years of use, your table is going to have a lot of nasty looking little marks in it, from tool bases gliding along, from taking dings out, from a little bit of rust that you had to remove, whatever. It's going to show after the years, and it's something you need to get used to. In fact, there's even a possibility that when you pull the table out of the box, there may be some minor marks on it, or I may have even removed some scratches on your table before it even got packed. So this is something you sort of have to get used to. When you're all done, wipe that down, get the grit off of there, and go ahead and shoot it with some WD-40. And when you're not using the table, go ahead and put a clear plastic tarp over it to keep moisture away from the table. And if you follow those hints, you should get many years of use out of your United Bicycle Tool Supply bicycle alignment table.